Thank you very much, and by rule, these are brief. So what is the objective? First off, the VSF has working groups, just saying that out loud. And that's one of the, where do these TRs, these technical recommendations come from? They come from the working groups that create them. So the ground to cloud, cloud to cloud, cloud to ground, GCCG working group, the objective was to figure out, study and document the content workflow from ground to cloud, within a cloud, and cloud to ground, and identify gaps, identify needs, figure out how to fill them. So that's what we've been plugging away at. Meets every other Thursday at 11 a.m. Eastern, and participation is welcome. There's a pretty good crew, and it's a pretty wide variety of people that turn up to the meetings, and I appreciate that. So one of the first things we looked at was establishing what are the operating points people run at today, particularly for contribution to the cloud and occasionally getting a work in progress back. And there's definitely a lot of people running in this kind of interactive latency, H.264 constrained, blah, blah, blah kind of zone. And these are, NDI and other things are sort of examples of this kind of application. There's also some contributions of cloud that go up in a more bandwidth optimized, very low rate contributions where you're trading away, sort of latency for having really long GOP codecs. But increasingly we're seeing, for high-end content, people wanting to do what we call premium compressed, so something like JPEG XS, and increasingly now the VSF Tier 08 and is published for that purpose, and Tier 09, you'll hear about tomorrow from Mr. Rayner, is a standard that describes, sort of the environment of how do you make connections between arm's length parties using these codecs, which is a key consideration whether you're going to the cloud or going to a fellow broadcaster. So if you think about the whole workflow and you say, where are the places that interoperability is required? So when you're going from ground to cloud, you need to define all the way down the stack to the packets, because that's really, you have to identify the entire stack of protocols. But inside the cloud, if you're going between instances, it's a little different, because there's cloud provider specific infrastructure that differs from provider to provider. And so what our goal is to identify the interoperation plane here in the middle and say, okay, there's a handoff of blobs of data that look a certain way, and the management signaling that goes with that. And then, of course, on the way back out of the cloud, the same way, the interop point has to be, again, the packet level. So what's the work for this? What's the work of the adjacent groups? So documenting this premium compressed use case has actually been done. So Tier 07 and 8 are done and published, and those relate to JPEG XS over networks. And Tier 09 is any day now. Is that a fair statement? Yes. And it's a good piece of work. You'll hear more about that tomorrow. Is there more that we should be documenting about the transport stream case? Well, the Tier 09 control plane can be applied to that class of streams, and the RIST work has been done. So a lot of work's been done there. We didn't feel like there was a lot more to do. One of the big things we focused time on was this time tagging, time flow model. And that's something that's fairly unique in the cloud production environment compared to all the other ways we've done it over the years. So that's something that we will have to document a vocabulary and some modeling and so forth. And that's the next big work item of this group, is to dive into really writing that down in a way that people can poke holes at, implement, understand, and use. And then, of course, the object structure, when you're going from instance to instance, how should you structure data? Well, there's a, in the AWS case, the CDI data handoffs are pretty well defined, but there's a lot of theories of other ways you could do it. So really the biggest thing we've been focused on in the group is this time variability and time floating challenge. How do you allow the software-based infrastructure to have the variability that it inherently wants to have, and yet preserve the meaningful time tags and timestamps of the original content in a way that you can knowably relinearize it at the back end into a stream of delivered time instances. So we've worked through a whole vocabulary about that. We have this fancy diagram that I keep reusing that talks about the shortest possible latency versus how much variability there might be, and defining for each step that variation and what's the worst case, what's the typical case, and how those can be then composed across a workflow to derive the end-to-end timing. So all that said, where are we at? So for ground to cloud and for cloud to ground, pretty much the tier 08, tier 09 activity is fit for purpose, and that group meets on the alternate weeks that we don't meet, and that's kind of a lot of people are in both. For the intra-cloud handoff, so between instances, we thought through, okay, how are we going to advertise receivers and senders? Well, we're going to extend NMOS to do that. How are we going to initiate connections? Again, we can extend ISO 5. It's a perfectly good protocol, just needs the specifics for this transport because they are different than others. Within that sort of protocol blob, how do we describe content? We'll wind up proposing to AMWA a little thing that, instead of, we're not going to use SDP, right? We'll use something more fit for purpose. What are the transport parameters? Again, they're provider specific, but there'll be a set for CDI. Again, we'll wind up proposing that. And this timing model is work that we have to document and publish as kind of our next big piece of work. And then data formatting, again, the canonical format number one is the CDI P group concatenated schema that's there today. Other buffer formats could exist. We just need a lingo for the sender and receiver to identify that they're using them. And then, of course, audio and metadata always get the short end. That's part of why audio is always the problem, is because everyone leaves it for last. But we do need to define sort of audio essence level handoffs. I kept hoping that AES had already done that. Maybe they have, but it's so small, it must be easy. And then for the inter-envelope, for the sort of arm's length handoff, if you were trying to go from, say, AWS to Azure, or if you were going between unrelated instances, even in the same cloud, but from completely different providers who don't have a shared security arrangement, you would probably wind up using a tier 09-like handoff, even if it was between instances in the same cloud provider, just because there's not a suitable security envelope or placement constraint. So all that said, we figured out, okay, here's the interop planes, sort of there, and now we're just working down how do I spec things at each of those points so that you can have different applications in a pipeline that are made by different people and composed by the end user. So that's where we're at.
Very good. John, thank you so much. Appreciate the update.